Every time an AI model makes a binary decision, like classifying an email as spam or inbox, it does so by drawing a line. This line is the decision threshold. Scores above the line are predicted as positive, scores below are predicted as negative. But because real-world data overlaps, some spam emails sneak into your inbox. To map every outcome, we lay out actual reality against the model's predictions in a 2x2 grid. This is the confusion matrix. We start with the correct predictions, where reality and prediction align. True positives occur when we correctly predict spam as spam. True negatives occur when we correctly predict regular email as safe inbox. In a perfect world, only these diagonals would exist. But models make mistakes, and they occur on the off-diagonal. A false positive occurs when the model predicts spam, but the email was actually a safe inbox message. This is a type 1 error, or a false alarm. A false negative happens when the model predicts inbox, but the email was actually dangerous spam. This is a type 2 error, or a misdetection. These errors are rarely equal. In spam filtering, a false positive is devastating and important work email is lost forever. But in medical testing, a false negative is unacceptable. A sick patient goes undiagnosed. By mapping every single outcome, the confusion matrix allows engineers to adjust decision thresholds, choosing exactly which errors to minimize and tailoring the model to the stakes of the real world.